Hi, my name is Cameron Simon.
Hi, I'm Kelly Madrick.
Hi, I'm Josh Shea.
Today we're going to talk to you about our electromagnetic spectrum operations demo. Why we're doing this demonstration today is because if you look at the terminals and missions that are used today, they all have their own front-end aperture and back-end processing equipment. So if you look at a SATCOM unit, there's racks and racks of equipment to provide those communications. If you look at an electronic warfare unit, there are racks and racks of equipment to provide that capability. And then if you look at a sense characterize mission, there's also racks of equipment to go and sense and characterize the environment. What we've done today is miniaturized all that into standard x86 software that's portable, scalable, and smaller footprint, and creates a multi-mission terminal that can be used multiple places, bringing that footprint down to multi-mission. So for the first part of this demonstration, we're going to be using Kratos OpenSpace to provide a standard satellite communications channel from point A to point B. And we're going to be putting that up over the air over satellite SES-1 for live communications from point A to point B.
Thanks, Cam. So this is our OpenSpace dashboard. We've created this specially for this demo. With OpenSpace, you can create unique dashboards depending on your user and their role. So in this dashboard, we've got a spectrum plot in the top left and a waterfall plot in the bottom left, as well as some predetermined courses of action in the middle. This allows users to just go in and execute this predetermined course of action for the signal. In the bottom right, we have a Google map of all of the sites that we have up right now. In particular, we're going to be looking at our Colorado Springs site today. So I'll go ahead and open that up. So again, this is a special dashboard we made for our Colorado Springs site. We have a driver that allows us to talk to a Hawkeye antenna that's on the roof of our building in Colorado Springs. This is showing the control and status up here. In the center, we have our RF input spectrum. The Hawkeye is feeding our digitizer, which has some x86 compute and a software modem running on it. So we're receiving 1 gigahertz of spectrum here, and we have our RF output spectrum on the bottom. You can see that we're not currently transmitting anything. At this point, we'll turn it over to Josh to take a look at our nominal signal that we're putting up that we're going to interfere with.
All right, you'll see here on the screen, we have actually changed the view. This is the KGSN, the Kratos Global Sensor Network, performing overwatch on that communication signal that we discussed earlier in the introduction. One of the things you can see here is that yellow line or trace. That is our active end user signal providing communications from end to end, or point A to point B. That orange trace down below, that is a representation of what our overwatch system is able to detect under that signal. Right now it appears as a flat line, meaning there is nothing there, and that signal is operating under nominal conditions.
Thanks, Josh. So at this point, we'll go ahead and turn on our first interferer. I'm going to switch back to the OpenSpace view. So we're back on the OpenSpace screen. We're going to execute course of action 0. What this is going to do is it's going to put up an interferer right in the center of the spectrum, and you'll see the scheduled item pop up on the scheduler as well.
So while Kelly's doing that, course of action 0 is a pre-programmed course of action that allows an end user to automatically run a specific course of action. So you can pre-build multiple courses of action in the software so that it automatically runs and a user doesn't have to be an expert.
So you can see the signal has popped up. We have our scheduled item here. At this point, I'll switch back to the KGSN and Josh can show us what we're seeing.
Now that we're back to our Overwatch view, you can actually see that orange trace. There is now what appears to be another signal. This is the signal that Kelly turned on through their system, and you can see that it does have an impact on that user signal.
At this point, I'll switch back to OpenSpace and talk through the schedule. So you can see our schedule item in the top right here. There's 4 key times. We have a start time, an AOS time, LOS, and stop time. We can use this to trigger and set up rules so that we can bring up and down our software modems, as well as configure them and get ready for pre-pass and post-pass and everything else. So at this point, we'll wait for the signal to come back down, and then we'll put up another interferer using our Hummer.
So Kelly, where is OpenSpace running right now that we see?
OpenSpace is running in Azure, and we can run in multiple clouds, and we can also run on-premise in x86 compute. So you can see that our signal is no longer transmitting. At this point, I'll switch back over to Josh at the KGSN, and he'll show us that the signal is no longer there as well.
Coming back to our Overwatch view, you can now see, just as in the beginning, that orange trace underneath our active communication signal is now flat, no other signals there. and our operations is back to a nominal state.
So you've seen how OpenSpace was used to run in the cloud and control a remote terminal on a network. Now we're going to show you a demonstration of a complete standalone system using our Hummer with a Chimeta phased array antenna and a standalone 1U Edge 2500 remote for the processing. And what you'll see on the screen in front of us is our Edge 2500 remote processing screen. And we're going to go ahead and enable the transmit for that and show a demonstration of providing that same interference you saw before.
All right, we have come back to Overwatch as Kelly is getting ready to enable all of the transmit equipment here on our Hummer with a Chimeta on the roof. You can still see that right now this our communication signal is operating nominally. Kelly, would you like to enable the Chimeta?
We just enabled the digitizer.
And we can now see underneath our nominal signal, we now have the signal that Kelly enabled. We can also see it is causing an impact on that signal and the communication on it is degraded. Whenever you would like, Kelly, would you be able to disable that signal?
Sure, Josh. So I've just disabled the signal.
And already on Overwatch for the live view, we can see that that signal is now off the air and we're back into a nominal operation for our user.
So now we're going to talk about how Kratos performed the EMSO demonstration, both in the remote and standalone demonstrations. And that was all done using our Edge 2500 remote that you see here in front of me. It's a 1U chassis that's able to be on a network or standalone. So when we did the on the network demo, we were actually remoting in through the Ethernet ports, providing that signal both from a receive and transmit perspective to cause that interference. In the standalone demo, we actually had a phased array Chimeta on top of the Hummer, where we have an embedded digitizer that provides digital IF or Diffie directly through to this, and we're doing the processing both on receive and transmit to create that interference and monitor that interference in the standalone and remote versions.